Hey, Algebra 1, doing your Unit 2 review, Part 2. So this is for the Part 2 review. If you go to the Google Doc, you'll see Part 2 that's listed on Monday. Okay, starting with number 1, find the domain and range of each relation, then determine whether the given relation represents a function. Okay, so first we got to figure out the domain, then the range, and then, as you can see in number 1, then we got to figure out is it a function or not. Well, the first thing is, when you're given just a set of points, both here in number 1 and in number 2, your set of coordinates, you're just going to list out all the coordinates that are all the numbers. Okay, so for remember domain, it's all the x values, range is all the y's. So I simply just take, for domain, I take all my x values. Okay, so that's 5, 8, 11, and 8. And then what I need to do is both start with a bracket and end with a bracket. And let me draw a little bit better bracket there. Okay, and I'm going to do the same thing for the range. And now, but this time, I'm going to take all the y values. So -2, -7, comma, between each number, 3, comma, 0. Is this a function? It's a function if every input or every x has only one output or only one y. Okay, so 5 only has -2, 8 has -7, and if I go over here, 8 also has 0. So 8 actually has two different outputs. That's not okay. So this is not a function. It would be a function if that 0, let's say, was -7 again. And as long as 8 has the same value every time, or the same output, you're okay. Okay, so number 2. Okay, same thing here. Okay, we'll list out all the x values, -6 in the mapping diagram, comma, -2, comma, 0, comma, 4. And I want to start with brackets and end with brackets. Okay, now do it in the range. Remember, the left side is the inputs are x, and the right side is the outputs are y. Okay, so for range, -8, comma, 4, comma, 12, and then finish with brackets. Now again, every input can only have one output. Okay, so -6 has -8, -2 has 12, 0 has 4, 4 has 12. So all these inputs here on the left, they all only have one output. They don't have a different one. And you'll be able to recognize that on a mapping diagram if, let's say, one of these numbers had 2 arrows coming off of it like that. Then you know it's not a function. But in this case, it is a function, so yes. Okay, number 3. Okay, so domain and range on a line. Okay, so the lines are a little different. Okay, so with the line, I'm not going to just write down a bunch of numbers. Okay, actually, let me get rid of that bracket. We may not use that. With the line, I first look to the left for domain, because domain, remember, goes left to right. So first I say, going to the left, does this graph go forever? And I'm looking at these arrows, and yes, they go forever to the left. Forever to the left for domain is infinity, -infinity. And to the right, it does go forever as well. And to the right is +infinity for x. So let me write that up here. -infinity to the left, positive to the right. So then that's the next thing I write, whatever is to the right. And when I have infinity, I always put parentheses. And then the range. We always go from, range is always y, and we start from the bottom to the top, or from negative to positive. And I say, does it go down forever? And yes, this goes down forever. And down forever is -infinity for y. So I'll write -infinity. Okay, and does it go up forever? Yes, it does go up forever. Okay, so up forever is positive infinity. And again, for infinity, we always write parentheses. Okay, now for this number 4, this circle. We always say start going from the left to right or from negative to positive. And does this go to the left forever? No, it doesn't. It stops right here. Okay, it stops right there on this circle. It doesn't go any further to the left than that point. And that point on the x-axis is -4. Okay, then we go to the right in the positive direction. Does it go forever? No. I'm going to put -4 here. It stops, and it stops at the positive value of 4. Okay, and when you have numbers, we represent that it stops at that point by using square brackets. Okay, now for range. For range, again, we go from bottom to top, or negative to positive. We say, does it go down forever? No, it doesn't go down forever. There'll be arrows if we showing it goes down forever. And it stops right here at -2. So that's my first number I write. Then we say, does it go up forever? No, again, it does not. It stops right here, and that's at 1, 2, 3, 4, 5, 6. Positive 6. So that's our top range. And again, for numbers, we put square brackets. Now let's answer the question on both of these. Are these a function? Okay. Now this one, again, for graphs or lines, we use the vertical line test. So you take a line, and you move this line. Let me see if I can actually grab this. We move this line across our graph. So from left to right. And we say, as we move across, does it touch the graph at more than one point? The answer is no, it does not. So because of the vertical line test, this is, and it does not touch a point more than once as it goes across, is yes. Okay. Now let's do the same thing over here. So as I take this line and I move it across, does it touch this graph in more than one place? Yes, right away it does. Right there you can see that, it touches both here and down here at the same time. So that is not a function. Okay. Number 5. Zoom up a little bit. Okay, so number 5, you're given a function. The function is f of x, and it's equal to 4x squared minus 5. And then it says find the output of f of 2. In other words, take this number, which is our input, and we're going to plug it in. We're going to plug that into right there wherever you see x. Okay, so do f of 2 equals 4 times, remember wherever you plug in x, we always write parentheses, 2 minus 5. Okay, now the first thing we do, and to go in order, is we do the exponents. Okay, so we do 2 squared, which is 4. So remember, 2 squared is equal to 2 times 2. Okay, now we have multiply and minus, or subtract, dot and knockus, but we do dot first. So 4 times 4. Okay, now we can do 16 knockus 5, or minus 5, which is 11. And when I write my final answer, I'm going to write f of 2 equals 11. Okay, that's my output for 2. Okay. And I can actually also write this like a point, 2 and 11. Okay. Now, number 6. Again, you're just going to take the input and plug it in where you see x. Okay, so f of 4 is equal to 3 to the 4 minus 2. Well, the first thing we want to do is exponents. Okay, so we'll do 4 minus 2, which is 2. So now it's 3 to the power of 2, or 3 squared. Well, 3 squared is also equal to 3 times 3, which is 9. So that's our answer. F of 4 equals 9. Okay. Okay, now this one is pretty much the same thing, except we're gonna use not just one input, but 1, 2, 3, 4, 5 different inputs, and we're going to have to plug them all in. Okay, so I can do this on a calculator very quickly, but just I want you guys to show work, so I want to see this at the very least. So I'm first going to plug in -3. So I'll do that here, -3, and then get your answer. Okay, so this negative and this negative become positive, so it'll be 10 plus 2 times 3, 6, so that'll be 16. Okay, I'm just going to go through each one. Then the next one, -1. I do the same thing and plug that in. Okay, now that'll be 10 plus 2. 2 times 1 is 2, negative times negative is positive. And then I'll go through and I'll do the next one, 0. And 0 times 2 is just 0. So my answer there is 10. And the next one I plug in is 8. Okay, so now -2 times +8 is -16. Oops. So it'll be 10 minus 16, which is -6. And then the last one is +5. So I'll plug in +5 here. And then -2 times 5 is -10. And 10 minus 10 is 0. So now I'm going to take all of these values that I just found, and I'm going to plug them into the table where the outputs go. So 16 goes here for -3, 12 goes here for -1, 10 goes here for 0, -6 goes here for 8, and 0 goes here for 5. And that's all you have to do is fill in that table, and those are your answers. Okay, I'll go ahead and stop there. That's page 1.